errors. No, stop, stop errors, X, stop. Exceptions, when something unpredictable happens. For example, this very nice robot, instead of using his gun to shoot, could just use it to a stick to be the best puppeteer ever. Hello! Today we're going to see chapter 4, Errors and Exceptions. The idea is that in 42, when something goes wrong, you can just throw an error. While when you want to talk about an unusual but expected behavior, you can throw an exception. That is, in the same way in Java you have checked and unchecked exceptions, in 42 you have errors and exceptions. And errors are the equivalent of Java unchecked exceptions. They can happen in any moment, and they are in some sense quite destructive. You really don't expect them to happen. While the exceptions are like Java checked exceptions, you have to declare them, but they are expected options. So you can program around them in a modular fashion because you know that they can rise. For example, we have here a method confirm answer that takes a num answer and is doing a syntax very confusing at first. So let's try to examine it step by step. We have x.pre, that is to encode a precondition, and we use the square brackets that we have seen for the list to represent a bunch of conditions that we know should always hold. We separe them with the semicolon. So answer must be bigger than 0 num, semicolon. This is the simplest form to put an element in our list of preconditions. Or we can have an answer that needs to be less than 10,000, and we can have a message. Here you can have a personalized message. And as you can see, I've not put a comma here because I think it reads better, but if I want to put a comma, I can. In 42, the commas are just white space. So I can put as many commas as I want, basically everywhere I want. In the same way I can put spaces. So they are just there to help readability. If we have something that can be reasonably represented as a string, we can use actual and expected so that we can check that the two-string representation of answer is going to be exactly equal to the two-string representation of 42 num. And the beauty of putting those preconditions in this way is that the system can check all of the precondition and can give us a good error reporting on which pass and which fail. So if anything at all here fails, we will not reach the execution in line 7. We will get an error. We can, recompute the answer as 6 multiplied by 7, and then we can add some condition. So we can just use x instead of x.pre for post conditions or other kind of checks in the middle. Of course, you can use x everywhere, but using x.pre gives you an error message that talks about precondition failure. That is probably what you want in this case. And again, notice how even if we format it on 2 lines, this is still just one condition, because there is no semicolon here. If I wanted, I could do this, or just this on a single line. Format it in the way you prefer. I can have another one, answer equal recomputed answer, and I could put it together in the list above just by doing this, but now I need to put the semicolon. Instead of using this syntax with a square bracket, we can just do error x and put our message. We can put an if, and if we get into a situation where we know that there is the error, we can just use error x. X works nicely with the enumerations, and it's a little bit surprising. You can, have operations inside of the enumerations and operations outside of the enumeration. And if you control all the code, you can always go in the enumeration and add the operation there. In 42, to use metaprogramming to inject the operation later. But maybe you don't want to go through this kind of difficulties and you just want to make basically a big switch. And I'm not going to tell you that you're wrong. Like in 42 you can do things in many different ways. Some are faster and some are more, conducive to maintainable code. But it really depends on a specific case what is what. So here we just want to go for basically a switch. So we have our directions and we have not put the opposite inside. So we try to put it outside. So in some other code, we can define opposite as curly bracket, because in 42 you can put curly brackets everywhere and they will just capture the return. And so you can have if d equal direction.north, return direction.south. If d equal direction south, return direction.north, and so on. And for the last case, if you just put an extra if, you will get an error. The system doesn't know that those are actually all the enumerations, and so it will tell you, hey, you have to specify what happened if none of those if are correct. And so an interesting way to express explicitly in the code the intention that this is the last case is to use an X. And so here we are requiring that D is actually west by exclusion. And in this case, we return direction.east. Now, we have seen about throwing those errors X. And let's see how we can make our own exceptions. Answer not understood as a kind of message. And yeah, this is the best terminology in Undertale. So the idea is that exception, error, they look like something is gonna be wrong. And sometimes it's the case, but sometimes are just a way to control the flow. And so we call the root of all these throwable things just message. Also, is this really the root? In 42, everything can be thrown either as an error or as an exception. But messages have methods that make it easier to process them and to work around them and to understand what they are trying to tell you, because they are messages, so they have information for you. Answer not understood, a class that we create with the decorator message. So message is an interface, but can also be used as a decorator. And this is quite of a common pattern in 42, where an interface can be used as a decorator to create instances of that interface. And we have to add some code. So we can have more methods for our particular kind of message, but the most common way to use this is to just specify which is the kind of message that we are implementing. So here we implement a message.guard. If you have seen other languages, you will have seen that we have assertions, and assertions can conceptually be disabled. So in 42, we try to capture this idea that some messages are always going to happen. And some other messages, well, the code may be twisted around so that they don't get checked anymore. And so the idea is that guards are always checked. You can write code that depend on a guard being raised. So if you want to use errors to or exceptions to control the control flow of your program, you should use something that extends message.guard. While if you are putting a lot of X's to debug your code and have better error messages where something goes wrong, you can use messages that are not guards. Error, answer not understood. Well, too bad. Messages are a kind of alphanumeric. How can we capture errors and exceptions? Here we show some code where, in order to initialize a variable called res, we have b1 equal a call that can go wrong, b2 another call that can go wrong, and here we could pass b1 because of course have been declared before and so is visible now. And then in line 4 we have catch error wrong, and we capture the error and we give it a name, message1, and then we return hi1 to res. So if something has gone wrong when we create b1 and b2, we can just produce a value for our result. And if we have another kind of message.guard, we can produce a different result. This is similar to what happened in most languages with the try-catch, where you have multiple catches that they are seen in order, and the first one that match is the one that is executed. Now, does not seem b1 and b2. And this is actually quite important because this will be wrong. Think about it. If can go wrong failed, b1 is still not initialized. So this piece of code, albeit it is syntactically nested inside of this block, so b1 is in scope, b1 cannot be accessed because it could be not initialized. Then we exit from this group of catches, and now we are certain that b1 and b2 succeeded, because if they throwed wrong, we have gone here, and that will be the end of this wall block. If it was any kind of message guard, we will have hi2, and we will skip all of this part. Again, this will be the end of this block. And if it was an error or an exception that wasn't any of those, then, well, we will exit from this block and the exception or error will leak out until a suitable catch is reached. So here the type system knows that b1 and b2 are well initialized. And here, when we use b4, we know that b1, b2, and b3 are well initialized. The try-catches in Java, Python, and many other languages, they are statements. While here in 42, you can use it as an expression. And the idea is that you are asserting that all of the initialization before have been successful. Otherwise, the catches will try to do something about it. And if they cannot, the exception will leak forward. This is particularly friendly when you want to initialize a variable doing something that can go wrong, as we show here. In Java, this is so much harder because you have scoping issues there. So you may have to declare a local variable without initializing, then you're going to make the try that have the curly bracket, and so it introduces its own scope. And then you have to eventually initialize the out local variable manually after the first part of code that have done the try and the catch worked out that there was no problem, and so you actually had the value. Now for a controversial topic. strong error safety. If you are a C++ programmer, you probably know about strong exception safety. And you know how hard it is to code correctly with exceptions. That is, code so that your objects are always in a consistent state when an exception is flowing away in the stack trace. And in particular, in C++, you also want to be careful that you are properly deallocating all objects. But exception safety is so much more than that. You need to check that you're not leaving objects in the middle of a mutation that leave them in an inconsistent state. In 42, we have two kinds of troubleshooting. We have errors and exceptions. And exceptions are declared, so you can reason about what can and cannot happen. On the other side, errors are not, so they can rise in any moment. And what if they rise in a bad moment? What we have if we have our mutable data structure and we have to keep something in sync when we mutate it. So for example, here we want to add 2 years to a person. But maybe something go wrong. And if something go wrong, in the second line, we may end up adding only 1 year. And this may be fine, but most likely it's not what you expected. You expected an operation either completely succeeds or it fails without any observable side effect. So this code will not be allowed in 42. You see, P is declared outside, and now you try to do something here in this block that can capture an error, and we don't know, we could see P with 23 or 24 years, depending on which of the two have caused an error. And outside of the block, we return this person again that we don't know how it is. Imagine, I don't know, that you have like your double map where you want to have all the elements going from one direction to the other, but also the opposite direction of the arrow. And when you add an element, you want to mutate both maps and add the mapping in both directions. If there is an error in between when you add the two elements, now you will have a corrupted map. 42 prevents this at the type level. If the person is surviving the scope that captured the error, the person cannot be mutated by the scope that captures the error. And same for any other kind of object, of course. So if you were to move the person inside of the scope, well, this will work now, because the person cannot be seen here. And so it doesn't really matter if it is 22 or 23 or 24-year-old. We have Bob going to its birthday. And so Bob's age is age plus 1. And then Bob get drunk and Bob get a party. And you look to this code and it seems like this code is keeping the 3 counters aligned. But what if Bob gets too drunk and there is an error there? Unfathomable drunkenness or something, And now Bob cannot have the party because they have to bring him away. And again, this is not what we expect by looking to this code. We prevent this. On the other side, if you have an exception, well, you know that trying to get more drunk is causing an exception. You have the information in the type system. And so you can modularly reason from the information that you have locally and plan ahead for the case where Bob gets too drunk. Now we look a little bit more on exceptions in the detail. So here we have an example for a method that prompts a user by opening a little GUI, and the user may provide a string result. But maybe the user just pressed cancel. This is part of the expected behavior, you know? Cancel is one of the buttons, so the user can press it. And so if the user press cancel, instead of getting a null result or an empty string, we can get a more descriptive cancel pressed exception. If we don't want to manually write it, but it's clear from the body that this is throwing that exception, in 42 we can just have an underscore. And this is like completely changing your life when you have to work a lot with checked exceptions, because they are checked, so they have to be declared, but they can be inferred. Just put the underscore to ask for the list of exceptions to be inferred. And now the compiler will examine the body of your method and see which exceptions are leaked. A typical thing that you often do is that you want to turn exceptions into errors. So, for example, you are trying to obtain some result, and you are doing something, but this something can throw an exception, file not found. And you want to turn it into an error, because in the logic of your application, the file should be there. And if it's not there, there isn't really an easy way to fix it. It's a disaster, it's an observed bug. And if the file is corrupted, again, it's an observed bug. You cannot really progress. In 42, you have a short syntax to do this. You can, whoops, file not found, file corrupted. So you can just write the keyword whoops and then list all the exceptions that need to be turned into error. With respect to, for example, Java, exceptions have two big advantages. First, they can be inferred with the underscore. So while you have to declare them, you may not have to actually type the fact that you are declaring them. And second, the very typical patterns in Java to capture an exception and wrap it into an error or a runtime exception, it's not really needed in 42, and the right, similar behavior can be performed by just using a keyword whoops. And that basically means something that was expected, whoops, it's not expected into the calling environment. So whoever wrote do stuff said, look, those are the various things that can happen. You can have a conventional result, or you can have one of those unconventional outputs that are still, correct part of the behavior of what can happen. And the user can just say, whoops, I don't expect this to happen actually. So it can restrict what the programmer defining the call do stuff thought was acceptable. And now the return keyword and how it works in 42. We have seen that you can have curly brackets, and the curly brackets can capture the return. So, for example, here we have x equal do stuff. You can catch stuff as an exception, and you return the constant a by swallowing the exception. Or you can catch any message.guard thrown as an exception, and you can do something and then return b. You can catch any kind of error message and throw your X. And you can have nested blocks where, for example, here you want to check that this cannot happen, and if it happens, it should be whoopsed. And so you can put a nested block so that you only whoops the guard that come out of do stuff and not any guard that come out from above. So as we have seen above, in a more compact way, you can see that it's quite convenient to use returns and curly bracket together with try catches. So you can have return plan A, do something, try to do it in this way. If there is a disaster, well, just try plan B. And the idea is that both plan A and plan B will return something that will be the result. Return looks similar to error or exception. We have seen above, that you write error something, exception something, return something. Is there a connection? Do we have 2 or 3 kinds of throwable things in 42? Well, indeed, return is just a kind of exception. And the curly brackets are just a way in the syntactic sugar to capture this particular kind of signal. So when you write numRes equal if blah return E1 return E2, this is actually desugared into a round block instead of a curly block. If blah return E2, return E1, return E2, and then there is this extra line. Catch return numX X. Basically, in this way, we are funneling the return result out of the block. So as you can see, the curly bracket block is just the round bracket block with a little bit of a twist to capture the return. If you come from Java, C#, C++, you probably don't want to think about this. You probably want to just stay under the illusion that return get out of the curly bracket, and that, yay, in 42 there is this special thing that the curly bracket doesn't need to be absolutely at top level in the method, but they can also be inside, and that's a nice way to have some more complex computation to compute a local variable. But if you come from a functional programming language or any expression-based programming language, then this may actually help you a lot, so that you know how we map statements into expressions in 42. And it may unlock you to be more direct when you code in 42. So, as a summary, always try to detect your code doing something unexpected. If you want, you can use not a guard, that is a message.assert, so that you can disable it to gain performance if it's really important for you. But please, please, fail your code. Your code needs to fail as soon as something deviates from your expectations. This is the only way to create code that can be understood on the long term. So it takes 2 lines, give a name to your issue, and then if something goes wrong, throw the error with that name. It takes a little bit of effort at the start, but it's so easy after. Use errors intensively, but use exceptions sparsely. They are really only needed in a few cases. especially when you decide some public libraries that work with mutable data, because otherwise strong error safety will prevent the fix. You will not be able to stop the error because your mutable data have been possibly changed, and so you will have to capture the error very late in the scope. So a public library working on mutable data should use exceptions, and if the user of the library wants to revert this decision, it can just use the WOPs. Near everything else in 42 should just use errors. And that's it. Next time, we're going to see caching. Finally, we have built enough understanding to express the real features of 42, the ways in which 42 truly get one step forward of all the other programming languages and let you write meaningfully more abstract code that can be reasoned modularly.